So here's the answers to that practice test, and I'm going to use, for this first question, I'm going to use these three properties of logarithms. Okay, we're just going to apply them. So if I'm looking at this first choice A, I know if I'm multiplying two numbers or variables, and I'm multiplying them, I write the two logs of each, and I add them, and that's not what's happening here. This is, I can multiply the log of 3 times the log of 4 instead of the log of 3 plus the log of 4. So that one's false. And if we look at B, that's it. Now this is the right form. I'm multiplying the two variables or numbers in the argument, and I'm adding the two logarithms. So that's true. This one, I'm going to look at this division property, and this says if I'm taking the log of a fraction, I can subtract the log of the top and log of the bottom. That's what's happening there. So that's true. Now this one has the denominator over the numerator, basically is what it's telling me, so that's false. It should be 3 over 4 log 3 over log 4, like part C. This one, I'm taking the log of, I'm dividing two logarithms. Well, that's not what the rule says. The rule says if I'm dividing two things and I'm taking the log of them, I can subtract the two logs. And this is I'm dividing two logs, and that's false. That's a classic one they'll try to throw at you to stump you up. This one says I've got an exponent, and if I look at the exponent rule, I can bring those exponents down in front, and that's what's happening here, so that's true. And that's the same thing here. Even though the variable is the exponent is a variable, I can bring it down in front, so that's true. This says the sum of two logarithms equals the log of the sum, and that's false. It's the product of the two, right there. And same deal here. This says the difference should be I should divide the argument, so that's the division rule, and that says I can subtract them, so that's false also. So that's how you answer the first set of questions. Now we've got an equation we got to solve. Okay, now I'm subtracting, I see. I've got two logarithms, so I'm going to write it as a quotient. It's base 10 because there's no number there. So x cubed plus 4 over x plus 1, and that equals the log of x squared. Well, since these are both equal to the same logarithm, it must be these two arguments are equal. So I'm going to write x cubed plus 4 over x plus 1 has to equal x squared, and I'm going to put that over 1 to make it a proportion. Now I can do the cross products. So x cubed plus 4 times 1 equals x squared times x plus 1. If I distribute the x squared through, I get this expression. Well, if I've got an x cubed on both sides, if I subtract x cubed from both sides, they cancel out. So that leaves me 4 equals x squared. And then to solve that, I'm going to take the square root of both sides. And when I take a square root, I have to remember it's plus or minus. So this is telling me x could be negative 2 and x could be positive 2. But I got to make sure both of those work in the original. Well, if I go back up here to the original, I try that negative number. That's going to give me negative 8, because negative 2 cubed plus 4. Well, that's a negative number. I can't take the log of a negative number. The same thing here, negative 2 plus 1, negative number. Can't take the log of it. So the negative 2 answer doesn't work. It's not a solution. It's an extraneous root, that's called. We did a number of those. If I spelled extraneous right. Alright, let's do the next one. So another equation, I've got the same log, I'm adding them, so I'm going to multiply the argument. So log base 2 of x plus 6 times x equals 4. And I've got a single logarithm, it'd be really nice to get rid of it. So here's the base, here's the exponent, here's the answer, so to speak. So I know 2 to the 4th has to equal x times x plus 6. So if I complete this, I'm going to get 16 equals x squared plus 6x. So now this is a quadratic. So I'm going to subtract 16 from both sides. And then I'm going to wonder if this factors. I mean, I could use a quad 83 program, but I think this factors pretty easily. I know 16 times 2, or 8 times 2 is 16, and 8 minus 2 is 6. Make the 6, sorry, should be 8. Make the 8 positive, the 2 negative. That'll give me the negative 16, positive 6 in the middle. So it looks like negative 8 and positive 2 are the two solutions. However, we got to check for extraneous roots. If I substitute in, I got to go back to the original. If I substitute in negative 8 here, I'm going to get a negative number. Same thing there. So the negative 8 is not a solution. It's an extraneous root. So we're going to cross that out. 2 is going to be the only solution. When we get to graphing these things, hopefully that'll make more sense to you. Why we get to cross out the extraneous. Oh, so now we're just supposed to expand this. So what do I've got? I've got a multiplication, and then I've got the square root, which I'm going to treat like an exponent. But let's treat this as easy as we can. So I'm going to write log base 7 of x plus log base 7 of y. Remember, I'm adding because I'm multiplying. Plus log base 7 of the square root of x over y. So we're almost there. We're going to deal with this part now. So I know the square root is, if I'm taking the square root of a fraction, I can take the square root of the top, the square root of the bottom. I'm just going to carry this along for the other side along for a minute. I know that if I'm dividing something and I'm taking the log of it, I can write it out as the difference. Whoops. Now I'm almost done because I'm going to copy this down so I don't lose it. Now when I take the square root of something, that's the same as raising it to the 1/2 power. So I can think of this as log base 7 of x to the 1/2 minus log base 7 of y to the 1/2, and now I've got an exponent which I can bring down in front. So to finish this problem off, log base 7 of x plus log base 7 of y plus 1/2, brought that 1/2 in front, log base 7 of x minus 1/2 log base 7 of y. And that is fully expanded, a big mess, but if we had to do some more with it, as we will in calculus, it makes it a lot easier to deal with than that huge problem in the beginning. Now we got to condense this. Well, I notice, one thing I notice, and this is like that problem, a couple of problems we did in class, I've got that 3 as a denominator. I'm going to factor out a 1/3 out of each of these things. So 2 log base 3 of x plus 4 log base 3 of y plus 5 log base 3 of z plus 7 log base 3 of w. And then I'm just going to start condensing this stuff. Well, I've got exponents here, right? I can bring those up. So I'll do that step for you. Log base 3 of x squared plus log base 3 of y to the 4th plus log base 3 of z to the 5th plus log base 3 of w to the 7th. Now, because these are all addition, I can just multiply all those things together, make it a single logarithm, x squared, y to the 4th, z to the 5th, w to the 7th, and I've got this 1/3 out in front. And to make this look a little easier, I know the 1/3 is an exponent, so if that's all in parentheses and I can treat it as it is, I can bring that 1/3 up above, treat it as an exponent, to the 1/3, and then I got to remember, hey, to make this look a little more tame, let's take the cube root of x squared y to the 4th, z to the 5th, w to the 7th. Okay, and that would be a slick way to leave the answer. Okay, where are we at? Okay, this is from the section 3. A number of you got this wrong last time. That's why I wanted to make sure you got it this time. So I know I have this equation's in the form 2000 e to the negative 0.43t. And I want to write this form. I want to make these two equations equal. Well, if it's 2000 the initial value, and I can think of that, I mean, the 2000s don't matter anymore. They're on both sides. I could divide them both by 2000 and be done with it. So then I see I've got this e. And I can think of that as that e to the negative power raised to the t has to be the same as b. Actually, let me call this b to the t instead of b to the x. So they're the same variable. So what these have in common is the exponent. So it must be those bases are the same. So for this problem, we're just going to raise e to the negative 0.43 power. And when I did this earlier, I got 0.651 was b. So to write the equation, y equals 2000 times 0.651 to the x would be the annual growth form. Question 7. This is a graphing calculator question. I wanted to make sure I threw it at you because this is where you are going to use this in life. Okay, so when you're on your calculator here, I'm going to write some stuff down before I use the calculator. I know I'm going to borrow a 4-year loan, which is 48 payments because there's 12 payments in every year. I know my interest rate is 3.5%. I know I'm borrowing $22,000. I need to find my payment. So on my calculator, if you press apps right there, I just pressed apps right there, that one right there. Okay, and then I'm going to type, I want the finance, so I'm going to either hit enter or type 1, and I want the TMV solver, so I'm going to type another 1. And as you can see, I've already got this typed in. I typed in 48. I typed in 3.5%. You don't have to make that a decimal. I'm going to type in my present value. My present value is how much I'm borrowing, which is $22,000. You can payment. You can leave whatever's in there. What you want to make sure you have the future value equals 0, because at the end of the loan you want to all pay it off. And we want to make 12 payments per year, so make sure make sure this end is dark. And then you just put your cursor down to the payment, you do alpha solve or alpha enter, and that's where you get the 491. So that's my monthly payment of $491.83. What's my total payback? Well, I'm making 48 payments of $491.83. You multiply those numbers, you get $23,607.84. So that's how much you pay back over the 48 months. To get how much this loan's going to cost you in interest, subtract off your original $2,000, you get $1,607.84 is what it's going to cost you to take this loan out. Okay. Last question. We know if we use an exponential growth model, okay, we can also use an annual growth model. In fact, maybe because this is annually, I'm going to take back what I just said. It wouldn't matter. You could do that. It just makes it a little bit harder to do. So I'm going to say y equals a times b to the x. This is decay. So to get b, I'm going to do 1 minus 0.0027. Remember, you got to make that percentage into a decimal. You subtract those two, you're going to get y equals a times 0.99725 to the x. We're looking for the x. We're looking for the t. Now, how does this half-life come into play? Well, if I take the present amount, I divide it by the original amount, that better be equal to a half if it's the half-life. Okay. So then we're going to take that log or the ln of both sides to get the isolate that x. So log of 1/2 or log of 0.5 equals, I'm going to use that exponent property, bring that x down in front. So then I'm going to do the log of 0.5 divided by the log of 0.99725 equals x. When I did this on a calculator, I got 251.7 years. Okay, so that test is going to look just like this, same kind of questions. I hope you do well on it.